Today we're testing this insanely compact dual 240mm radiator custom loop that I built in the Ncase M1 in my last video. We've got a slim 240mm rad at the bottom paired with a couple of slim fans and a 38mm thick 240mm rad from EK mounted on the side. What I'm really interested to see here is how the thermals compare to my own system, which also uses an RTX 2080 Ti, but is around 3 liters smaller and only uses a single 240mm rad. So this is pretty much the densest Ncase M1 that you can build, and to put this into perspective, there are plenty of mainstream mid-tower cases out there that don't have this much radiator volume that they can accommodate. So let's see how this thing actually performs. For those that missed the initial video, this build uses an RTX 2080 Ti, a 10900K, a low profile 32GB kit of 3000 MHz memory, 2 full copper radiators, a bunch of soft tubing, and a few tightly packed compression fittings. Also, since this build has no reservoir, I had to be really patient in filling up the loop to the brim. Ideally, you'd connect an external reservoir via the quick disconnect fittings, and then bleed the loop with a high pump speed over a couple of hours. The pump that's running the entire loop is the 4500 RPM DDC pump that comes mounted to the SwiftTech Apogee Drive 2 CPU pump block. I saw a few comments asking whether this was indeed powerful enough to run the entire loop, so I've done some testing here at a few different pump speeds. The setup for airflow has both radiators taking in fresh air from the exterior and then exhausting that into the case. But because the Ncase M1 is so well ventilated, the hot air doesn't really have a problem making its way outside of the case, and that's made even easier thanks to the 4 total fans. There is quite a lot of pressure in there. The result is that most of the hot air ends up exiting through the top and the rear, and also a small amount at the sides just above that bottom radiator. So a lot of the thermal testing that I did here is just aimed at answering quite a few questions that I had with this build. For example, how fast do we need to run that pump? How fast do we need to run the fans? And is there a big difference between the dual radiator configuration and just the single radiator at the bottom? Let's start off by taking a look at that RTX 2080 Ti, which is undoubtedly what's going to contribute most of the heat into this loop. And running it completely stock with the fans at 1500 RPM, the 2080 Ti sits at just 50 degrees C, which is a pretty mind-blowing result for a PC under 15 liters. Now, I've outlined the benefits of GPU undervolting in many previous videos, but in short, if you want to significantly reduce power consumption, thermals, and coil whine, there's no better way to spend 5 to 10 minutes. With a fairly conservative undervolt on the 2080 Ti running 1900 MHz at 900 millivolts, we get a 7-degree reduction with the GPU now at just 43C. To illustrate how good these GPU thermals are, let's go ahead and compare this to my own personal rig, which also uses a 2080 Ti, but on a single 240mm radiator. So there's around a 13C difference between them, and at 63C, that's a fairly warm result for a water-cooled 2080 Ti. This is the main reason that I run a permanent undervolt for my GPU. As for CPU thermals, well, we can only reduce that so much by adding more and more radiator volume, because there are other limitations such as the thermal transfer between the CPU die and the heat spreader, and then the heat spreader to the CPU block. Having said that, we do get a very respectable result for our 10900K, which is running with unlimited power on the MSI Z490i Unify motherboard, pulling close to 200 watts and running at 4.9 GHz. VRM thermals were also absolutely fine here, despite a lot of concern for how densely packed this build is, settling under 60 degrees C after 30 minutes in Blender. Fan speed does play a big role for this build too. Decreasing all 4 fans down to an almost silent 1000 RPM saw the GPU temp jump by 6 degrees C as compared to 1500 RPM, but it's still within a very safe range. Also, this is with the stock 2080 Ti pushing around 260 watts into the loop, which makes this even more impressive. You could probably get it back down to that 50C mark with some undervolting. And for those who were questioning the pump choice, be assured that it's plenty fast enough to run this build. By increasing the pump speed from 2500 RPM to 3750 RPM, we only see a 2-degree reduction, and by reducing it to its minimum speed, just 1250 RPM, the result isn't that much warmer at all. Beyond 3000 RPM is where this pump starts to get audible, and honestly at its max 4500 RPM it is insanely overkill and not really worth testing. You could totally run this loop at 1250 RPM if you really wanted. And lastly, just because we can, let's see what happens when we disconnect that side mounted radiator from the entire loop and leave that bottom mounted radiator to cool the entire system. Well, it is still viable, and I have seen a lot of Ncase M1 loops designed this way, but you'd probably need to undervolt the 2080 Ti. The dual radiator configuration is significantly better and highly recommended. And lastly, here's a quick look at the noise levels between the two tested fan speeds. So after taking a look at the thermal performance of this build, I think we can pretty confidently call this a no compromise ITX system. It runs significantly cooler than my own personal rig, which uses a single radiator, and it really crushes anything else that I've built previously under 20 liters. While it might be a bit overkill for a video editing and esports gaming machine, which I've optimized my current smaller machine around, this is seriously perfect for those that need to cram an uncompromising level of power into a tiny case. Now, of course, there's no such thing as no compromise, right? Especially building ITX, there are obvious compromises, like you can't put Threadripper in here, you can't put multi GPUs in here, and you can't put multiple 3.5-inch drives, especially with the amount of sort of space that's taken up by the radiators. But in terms of raw performance, thermals, and noise levels, this is the best ITX machine that I've ever built to date. And although I'm not going to be using this as my personal build just yet, I do eventually see myself arriving at this configuration when I do need more power and more cooling. For those of you who are interested in the parts that went into this build, I will leave them linked down below in the description, as well as the initial video if you happen to miss that. As always, a huge thanks for watching, guys, and I will see you all in the next one.